All right, let's do one more example. This time, let's reverse the process. This time, let's say we're given the zeros, and we want to find a polynomial function that has the given zeros. Now, it's not as though I can say, all right, I'm given this polynomial, x equals 4 and x equals 1 plus 2i are zeros, because I need a degree 3 polynomial. What do we need to know? Well, if we have a third degree polynomial, that means we have to have 3 linear factors. Well, what linear factors do we know? Well, because we're being told that x equals 4 is a 0, that implies that one of our factors must be x minus 4. X equals 1 plus 2i also implies something. In this case, it implies that x minus the quantity 1 plus 2i must also be a factor. That's one thing. But we have a polynomial that has degree 3 and has only real coefficients. And the last time we came across complex number zeros and real coefficients, we had that complex pairs theorem, which stated that it means that x equals 1 minus 2i must also be a 0. And so our third factor will be the quantity x minus the quantity 1 minus 2i as well. And so these are the ones that we're going to use to factor to get our polynomial p of x. This is a polynomial, but it'll work. This particular polynomial can be found by just multiplying our factors, x minus 4, x minus the quantity 1 plus 2i, and x minus the quantity 1 minus 2i. And of these three factors, let's just multiply together in pairs. So let's take this last pair right over here and multiply it together. I'm going to ignore x minus 4 for the moment and just multiply it in the end. It seems to be an easier factor to work with, but these two factors over here at the end, here's how this should work. Right? By our FOIL method, x squared. We're going to take x times 1 minus 2i, so that's minus x times 1 minus 2i as our outer terms. We distribute x to the inner term, right? So we got minus x times 1 plus 2i. And multiplying together our two last factors, plus, we're going to have plus 1 minus 2i and 1 plus 2i. So it'll be good for us to simplify this out before we begin doing anything else. I'm going to take x minus 4, and that will be multiplied by x squared. Let's distribute right here, so we're going to have minus x plus 2i times x. We're going to distribute here, so we'll have minus x minus 2i times x. And we're going to be adding to that 1 minus 4i squared. Simplifying one more time, that'll give us x minus 4 times x squared minus 2x plus 2ix, and minus 2ix will cancel. Minus 4i squared is the same thing as plus 4, so it's 1 plus 4 plus 5. And so now we would need to multiply these two together. And one way of dealing with it would be just to distribute. Let's go ahead and distribute x minus 4. Actually, you know what? I'm going to do this vertically. I'm going to take x squared minus 2x plus 5. I'm going to multiply that by x minus 4. So multiplying by our 1's, we've got minus 20. We've got negative 2x times negative 4, that's plus 4x, plus 8x, pardon me. We take x squared times negative 4, so we'll have minus 4x squared. Going with our x's, we're going to have plus 5x. We're going to have negative 2x times x, that's minus 2x squared. And x squared times x gives us x cubed. So when we add these together, we've got x cubed minus 6x squared plus 13x minus 20. And so p of x, when we simplify it down completely, should be x cubed minus 6x squared plus 13x minus 20. Well, there we go. That's what we were looking for, and so we're done.